I think I should be live. If anyone's already here, say hello in the chat. If you can see or hear me, that would be great. If you want to let me know. And I know we're like a minute early. We're going to wait a couple minutes before we really get going. But while we're waiting, cool. Yeah, I see people are here. I'm going to check the stream on my end. Looks like it's working. But again, while we're waiting, it's always great. If someone in the chat, in the live chat here on YouTube, just wants to say that you can hear me okay. It's always good for me to double check. And also, for anyone watching, if you want to put maybe where you're watching from, it's always really fun to kind of see, not only for me, but also for everyone else in the audience, like who else is watching. Scott said, we copy. Awesome. Thank you. Thank you for letting me know. Again, it's always good to double check. I'll think everything's working fine, and then my audio went out or something. That's happened to me before, so I try to always double check now. How's everyone doing today? Again, we're going to wait a minute probably or so before we really get going here. So I see more people joining in. I would encourage you to say hello in the chat. It makes it way more fun for me, but I think also for everyone else here. And if you also want to put in the chat, maybe, again, where you're watching from is always fun to hear, but also maybe you want to say why you're interested in machine learning. That would be fun to hear as well. Do you have a project in mind already? Are you looking to do a career change and you want to become a machine learning engineer or work in a similar field? Let me know in the chat. And Scott said, it's been a great day so far. My day's been pretty good, yeah. Just been working, doing a lot of fun stuff at work, and I'm excited to do this. I've been wanting to do another kind of intro to machine learning for a while, so this will be really fun, I think. Just sharing my screen now too, and again, we're gonna wait a minute or so, probably another minute before we get going. I see people are still rolling in, so I'm gonna let people roll in just for another minute or two. Someone said they can hear me and they're watching in Seattle. I guess I should also say I'm streaming from Seattle. So, and another person from Seattle. Perfect. I guess I did post this in a Seattle meetup. And there was, I think, over 200 people RSVP'd, which was pretty exciting. Scott said from Tacoma. Actually, I want to go back down to Tacoma. I haven't been down there in a while, and I want to go hang out and check out some places there. One of my favorite donut places is in Tacoma, which is Pow's Donuts. If you've been there, it's fantastic. Somebody said they're a data engineer and they're interested in branching out and going more into ML and ML ops. Awesome. Very cool. I mean, that's such a great background to have too, coming in as a data engineer. And if you want to switch into like ML ops and do more of that, I think that'll be, I don't want to say super easy, but you're going to have such a good background to go in and do that. Somebody said, watching from Portland. Awesome. I'm actually supposed to go down there this weekend if it doesn't snow a lot. So I'm in Seattle. Driving down there might be a little sketchy if it snows. Someone said Redmond. Also a whole bunch of people in Seattle. Awesome. Someone said it's chilly in Los Angeles today. Someone else from Tacoma, and they agreed. Pow's is incredible. Yeah, it's fantastic. I love that place. Every time we're coming back from somewhere, I usually stop by because I don't get to go there too much. Feel like it's way better than most other donuts in Seattle, but people could correct me if I'm wrong if you have a favorite donut place in Seattle. And again, I see a lot more people just joined, so I think we're going to wait another minute or so. But while you're joining, say hello in the chat. It's really fun to see where people are watching from. But again, if you want to throw a little bit more details in there, that would be great. Like, why are you interested in machine learning? Do you have a specific task or project in mind, or a specific career? Maybe even a company that you want to work at. That's really fun to hear about. And also helps me maybe target some of the material as I go through, just to kind of keep in mind, this person's, trying to do something. Maybe I can go a little deeper into that subject. So many people are in Seattle. Do you think it's actually going to snow tomorrow? I'm not sure. It seems like the weather is flip-flopping every time I look at it. And I'll just share a couple links actually while people are joining, and then we'll go ahead and get going in the slides here. I should have had these up. I think they're actually also all the links, pretty much all the relevant links that we're going to need are in the description below. So you can actually just pull up the description, click on things as we go there, but I will also try to share them in the chat. And the most important thing is going to be this GitHub repo. Again, these are in the description. So also, if you're coming back and watching the recording, which is at this same link, you'll be able to get all these links later as well if you can't find them in the chat. So there's a GitHub repo here. That's going to have the link to these slides, actually, if you want to look at them later. But the most important thing for this workshop is going to be the Colab notebook, which you can click on this link or this link here, and I'll open them up into Colab. And we'll talk more about this tool and stuff later. So don't worry if you've never heard of Colab. It's just a tool that's going to make it easier for us to run all of our code today with some minimal setup. So that's a direct link to it if you can click on those. But if not, again, I'll get to the setup as we go. These are just kind of while people are joining, if you want to go ahead and check that out. And then one other one, let me get this real quick from the slides. So I won't be looking in the Slack or anything during the workshop. So definitely keep the conversation in the live YouTube chat for now. But there's a Slack channel that I hang out in a lot. I'll talk a little bit more about what that channel is actually about and some of the other tools I'm working on. But it's an open source MLOps tool Slack that the company I'm part of helps maintain. So I'm hanging on there. There's a channel for ML and MLOps if you want to ask questions there later. So again, keep the questions in the chat during the workshop. But if you want to go ahead and join that Slack channel, and there's an introductions channel too. I think there's already almost 3,000 people in there. So it's a good place of like practitioners, a good place for practitioners to stay connected and ask questions later. You can go ahead and join that as well. And I think that's kind of it for the stuff you'll need. Again, we'll get to all those links again as we go, but it's kind of if you want to preemptively look at them. So I'll get the slideshow started here. And I know a lot of other people commented like where they're watching from. I think people were also hypothesizing if it will snow. Someone said they don't think it will. Some said it's already kind of sleet over in Redmond. Interesting. Yeah, we'll see what happens. And someone said it's been snowing in Mukilteo. Interesting. All right, is everyone ready to go through some of the material here? So we're going to start with some slides, and then we're going to go and do hands-on code as well. So just to make sure, everyone's kind of caught up with what they need to know. Actually, I'll talk more about this here in a second. So what is this workshop? So again, it's an intro to machine learning with Python and scikit-learn. Hopefully, this is a super friendly introduction to machine learning with Python. So this is designed for you to really have no previous experience, but knowing some programming will be helpful because we are going to actually do a hands-on portion today. But even if you've never programmed before, you'll be able to stay on today and run the code. Maybe there just might be parts you have more questions about it, but you'll actually be able to run the code. We're going to use Python, but you'll be able to run it even if you've never used Python before or done a lot of programming. But knowing some will be helpful, kind of just so you know what's going on when you look at the code. But I will try to explain it as we go. And also ask questions. So I am monitoring the chat. Like when I'm looking over here, this is me looking at the chat. I'll try to get to most questions. If it's really busy in there, I might not see everything. And feel free to ask a question. And if I don't get to it, ask it again. Hopefully I just didn't see it. Or you can also connect with me later and ask me that question as well. So we're going to cover some high level concepts in the slides. This is going to be the first part. And this is just to be like, if you've never done machine learning before, which again, it's designed so for no previous experience expected. So I want to kind of go over some of the high level concepts. So even if you've heard of machine learning a little bit, but maybe you don't know some of the different types and stuff like that, we'll cover that. And then we're going to go train a machine learning model with Python. And then also just keep in mind, you can't learn everything in, about the hour, or maybe we'll go a little bit over. But you certainly can't learn everything about machine learning. So I really hope that this just kind of gives you a really good introduction and maybe breaks down that barrier of if you thought machine learning wasn't for you or thought it'd be really, really hard to get into. I hope that you'll come away today being like, even if I didn't have any experience, I was actually able to go train a model. I kind of understand the concepts, what's going on behind the scenes, and then you could keep learning and become a machine learning engineer, make that career change, or build that cool project that you're thinking about. So again, depending on your background, this could feel like fast-paced or challenging, and that's totally okay. That's how you learn. Just keep learning after this workshop, and then I'll reiterate, ask questions in the YouTube chat as we go, and I'll try to answer them. And also feel free to answer questions. So if people are asking questions and I don't answer it, and you know the answer, feel free to answer that question in the chat as well. So quick introduction about myself. My name is Sage Elliott. I do a lot of stuff with AI, machine learning, and ML ops. I'm at a company called Union AI. We actually build a orchestration platform so you can kind of run, deploy, scale any AI workload. So this kind of comes after you've done this. Today we're going to talk way more just introduction, ML, and stuff like that. We're on the putting machine learning and AI in production side. So once you actually know how to train models, which is what we're going to be looking at today, you actually want to put that model out in the world and interact with users and build a really robust AI infrastructure around your model. We're one of the tools that can help you do that. So you can check out union.ai if you're interested in something like that, or hopefully, maybe if you're new and you're learning machine learning today, and maybe in a couple months or whatever, when you're building a machine learning model in production, you can check out our tool as well. So for over the last decade, I've worked in software and hardware and machine learning, mostly with startups and some agencies around Seattle and Central Florida. And in general, I love making things with technology. If you want to check out, didn't mean to go away from the slides. Check out the open source project that we help maintain at Union 2. It's called Flight, completely open source, free to use. This is also one of those MLOps tools, again, that you can use to put your model in production. And it's open source. We always appreciate a GitHub star. So if you want to give that a GitHub star for me doing that workshop, or for this workshop, that'd be awesome. And then also, if you want to stay connected with me later and ask me questions, you can do so on LinkedIn or in the Slack channel, which again, these links are in the description below. So I saw more people join in as well. About you, I want to take a second again for everyone here. Where are you watching from? Why are you interested in machine learning? Put those into the chat. And then if you want to stay connected and make a little bit more of a permanent introduction to way more people, there's an introduction channel in the Slack channel, and you should do an intro there. Again, I won't be looking in that Slack during this workshop, so keep the questions for this workshop here. But if you want to ask questions later and connect to me, that's going to be a good place for it. And yeah, make sure you say hello in the intro channel. Somebody said, can I post the slides? They're actually linked in the GitHub link. So if you go to the description or scroll up in the chat, there's not the Flight GitHub link, but there's a GitHub link in the description of the video. And it goes to a GitHub repo that has a link to the slides and to the Colab notebook. But I'll make sure I will do a follow-up email, I think, too. And I think I can do that in a meetup just to everyone who RSVP'd. And then I'll share the relevant links out again, including the slides, if that works for everyone. So setup again, just for anyone joining. And we'll go over this one more time when it's time to run the code. All you need is a modern web browser. You need a Google account. I'm guessing most people already have a Google account. This is just so you can save your code, because we're going to be using a tool today called Google Colab. And you need a Google account to kind of save the progress and your code there. I'll copy this link into the chat again, but it is in the description as well. That's also the GitHub repo that I was saying has a link to the slides. So again, we're going to be using Google Colab. We'll talk more about this later, but it's a way to run code and look at visualizations online. It's really cool. We're going to be using Python, which is one of the most popular programming languages in general, but also incredibly popular for the machine learning data science field. It has an incredible ecosystem of libraries that make it way easier to do things like machine learning. We're going to be using a library called scikit-learn. It's also a really popular machine learning library in Python. We'll take a look at some of the algorithms in this later. And we'll also be using something called pandas, where we can create a powerful thing called a data frame. Again, we'll look at this when we actually run the code in the hands-on portion, but it allows us to look at data and do data manipulation in really cool ways using Python. So what is machine learning? So to put it really simply, you can think of machine learning as a statistical model based on a data set to solve a problem. So instead of explicitly programming an algorithm, like if you've done programming before, you might specifically have these kind of rules that you make saying, like, if a number is equal to something, do X, or if it's less than this, do Y. Instead of explicitly programming out like a giant decision tree of if statements, we actually just have this function. You can think of it as a programming function, mathematical function, and then you're going to give it data, and it's going to learn patterns from that data. Usually the data is pretty complex, where it wouldn't be easy for you to manually create those like if statements. So it's going to be a complex data set typically. You're going to pass that in. It's going to learn patterns from that. And then you'd be able to take new data once you've trained your machine learning model. Again, we're going to actually go through and do this step today. We're going to take data, pass it into a machine learning model, train a model, and then we'll pass in some new data to it and see it make a prediction. So once it's learned those patterns, you can give it data from production or in the field that it's never seen before, and then it can make a prediction on that data, like does it belong to a certain class, or what would be the price of this thing that it's looking at. And we'll see examples of this here in a second. But just keep in mind, machine learning is just really good at finding patterns in data. So who uses machine learning? At this point, I think it's fair to say like almost everyone. I'm not every single person, right? But like every company and field. It's hard to think of ones that aren't probably using ML in some capacity. So more and more companies are using it to make decisions with data or with machine learning on their data. Here's just a few examples you've probably experienced or maybe even thought about so far. Like if you open up Netflix or any of the streaming services, it's giving you product recommendations or movie recommendations. It doesn't have to be movies. It could be any store. Like Amazon is also giving you product recommendations of what it thinks you're going to want to buy next, because there's just so many things on those platforms. It would be hard for you to find what you're looking for in Netflix probably if it's not serving things that it thinks you would enjoy. Digital assistants, you've probably used or seen things like Alexa and Siri, and now some maybe better ones using like GPT or these like the recent developments in large language models, which is really cool. Delivery robots, other types of autonomous robots, Amazon Go. Has anyone actually been in Amazon Go before? Since there's quite a few people from Seattle here, I'm guessing some people have. If you've never gone in, it's really cool. You go into a store. If you look up, there's an array with like a ton of different cameras looking at you. And then it uses computer vision to track you when you go in. You scan a QR code, so it kind of knows who you are. And it has a payment method tied to you. And then you can pick up stuff and shop like you normally would. But then you just walk out, and it used computer vision to track what you picked up. And then it will charge you for what you bought, which is really cool. Email spam filtering. If you're younger than me, you might not have experienced this, but I remember when spam filtering was just awful. You'd get stuff all the time in your Yahoo inbox back in the day. And then I feel like Gmail really did an incredible job with spam filtering, and everyone got really good at it. And that's using machine learning as well. So it's, looking at what spam emails look like, and it's retraining that model over time, because people try to get around that model. They want to take the new spam emails, train this model in production, or that's out in production, and then kind of update it over time. And that's a very common theme with machine learning too. You train a model, that's really just a small part of it. Once you have it in production, you're often looking at it all the time, collecting new data, retraining it, and deploying new versions out into production. Self-driving cars, chatbots. Again, these are just ones you've probably seen or interacted with pretty regularly. But I want to talk about some other machine learning applications. People will often think of stuff like this, like big tech, but there's so many really cool industries using it right now, like agriculture, manufacturing, a lot of smart home things, healthcare. Does anyone else have any other fields that they're excited seeing more AI applications come to? I've seen like dentistry using it. There's obviously now a lot of generative stuff as well, which can be exciting. If you're excited about like images or text generation, that's been an interesting area, obviously, in the last year. But yeah, does anyone have any field? Oh, someone said finance. That's a great one. Yeah, I should totally have put this in here as well. And finance is a really interesting area. And we'll talk about this later too when selecting an algorithm. But with things like finance and some of these other industries like healthcare, there's so much scrutiny. That might not be the right word. Like you want to be really you want to be observing your algorithms and making sure they're making fair decisions. So you actually need to, again, implement a really good MLOps kind of structure or infrastructure around your AI product, where you can be looking at, why did my finance algorithm make this decision, or why did my healthcare algorithm make this decision? And if it's doing bad things, I can quickly catch it and retrain the model, so it's no longer doing that. So it said automotive, very cool. I wonder if that's probably for driving, but there's also a lot of manufacturing stuff with it as well. Someone said, do you have to establish the rules for data? Yes, no, for ML to start working with data. Not really. So you don't really, you might be able to do some stuff like that sometimes if you want, but what you're really going to do, we'll see this, I think, in the next slide. You're going to give it labels a lot of the time if you're doing supervised machine learning, which a lot of machine learning is. And we'll talk about those different types here in a second. You're going to give it labels, and it's going to learn the rules that kind of belong to those certain labels. So I think it'll make sense when we see it here in a minute. Somebody said recycling plastic. Somebody said they worked there. I assume that was for Amazon Go, maybe. That's cool. I thought it'd be interesting to work there. And I don't know if you had a good time, but I do feel like employees there are often kind of more happy because they're not forced to interact with people because you don't have to check out people all the time, which I thought was cool. So it said smart energy grid. That's a good one. Transportation. They said they heard Logic Pro drummer uses ML. I assume that's can make drumming noises. I think Logic Pro is a music editing thing from Apple, I believe, right? And I would believe, yeah, actually, music and ML is a very interesting place right now. I think where we're just at the beginning of generative music. I think that's going to change probably this year. That'll be interesting to see what happens, and like see what happens on the legal side of things too, right? Like, is it okay to have that? I mean, you see this in a lot of generative AI, not just music, around what goes into the training data, and is it okay that you're generating things pretty similar to it? Someone said supply chain management. That's also a really good one. Yeah. So as you can see, people are just listing out a ton of these really cool industries that I didn't even have here that are using machine learning today, and where they're still trying to make a whole bunch of really cool improvements. So it's exciting. Like, you can have a background from anything, healthcare, for example, radiology, and be getting into like ML as a field, and you're going to bring all that background knowledge you have into looking at data and models, and that can be incredibly helpful. So if you are like working in a different field, like I actually did a lot of stuff in manufacturing a long time ago. That's actually what got me into machine learning, is I was trying to manufacture a complex part, and I ended up building a computer vision algorithm to look at it and decide it was good or bad. And that's what got me into machine learning. And I got to bring that tool into a manufacturing setting. So I think like having these backgrounds and then seeing where these problems are and how you can improve it, and then you get to bring that skill set in, is incredibly valuable. So let's go talk about some different types of machine learning. And again, feel free to keep sharing different industries in the chat. I think it's really cool. I'm just going to keep moving on the slides so we can go through all the material. So someone is asking about kind of how do you tell a model to learn. So we'll talk about some of the types of machine learning. One of the most popular types right now is called supervised machine learning. And that works by you pass in a data set to your algorithm that is labeled. So this is actually what we're going to do today. This is a little sample of a data set. We have these 4 features. So these features are the things that you would be trying to make a prediction on. So in production, you wouldn't actually already have these labels like with new data coming in, but this is your training data set. So what we're going to do is pass in this data set with these 4 features. So in this case, it's sepal length, width, petal length, and width. And that's a measurement of a flower. So you have a petal on a flower, and you have a sepal, I think is kind of like an underbelly petal. Like they're I think that's it. I think I looked it up before, and I had to learn it because it's always in this machine learning problem. So you have these 2 measurements of flower, pieces of flower, or 4 measurements. And then just based on these features, you're going to try to determine what class it belongs to. So we would feed all this data. In this case, we're going to use 150 samples today, train our model on that. And then you would pass in just features, like just this without the label. And then it would try to assign the correct label to it. And that's supervised machine learning classification. So we're trying to classify it belonging to a certain group, or a label in this case of a class of flower. Another type of machine learning, or another example here would be spam or not spam is a good example, actually, right? Is it spam, not spam? That's like a binary classification problem. You're saying it's one or the other. In our case, we're going to be doing multiple classes and predicting 3 different classes based on just this coming in once we train our model. And again, this will make a lot of sense when we go through and program this. Regression is another type of supervised machine learning. You'd pass in features again, just like we did before, but with a regression model, instead of trying to classify a group that it belongs to, you're trying to classify a kind of a running number. Like in this case, it could be anywhere between like 0 and hundreds of thousands. So it's more of a linear number that you're predicting, not a just like a bucket. Like before it was only 3 classes, this could be like any number. So this is really popular when you're trying to predict things like price for a house, for example. So here's like a classic problem. If you had like crime rate, zoning, number of rooms, square footage of a house, could you predict the price of it? And so that would be a good example of a regression problem. And if you want to turn it into a classification problem, you could almost maybe have like 3 buckets. So you could say like, this is cheap, medium, expensive, then that would be like a classification problem. But since you want to get the actual number, it's a regression one. So some other areas you might see like stock prices, age, again, anything with like a linear number that you're trying to predict from. And I'll just quickly note, so I talked about, I always like to bring this up even this early on if you're incredibly new to machine learning. If you trained a model with prices, let's say, 10 years ago, chances are like the housing market's changed a lot. So you would want to retrain your model with the current data if you're actually trying to get an accurate prediction. And that's kind of where, when you have an infrastructure thing set up, you can like monitor your models in production and see how accurate it is. Maybe there's something called data drift, which happens when the new data coming in production no longer really matches the data it was trained on. And you want to take all this new data and then retrain your model, and then you'll have a better model. You have unsupervised machine learning. So you can kind of think of this as clustering. So here we have those features of petal width and sepal length plotted out. In this case, they're kind of color coded to which flower they belong to. But imagine we didn't have these colors here. You could kind of probably draw a circle guessing that, well, these features might belong to something. Like there's a pattern here. There's maybe another pattern here. And then here, there's definitely a pattern where all of these features kind of are clumped over there. So this can be really cool if you have a ton of data, but you don't really have them all labeled, or there's not a good, clear way of labeling it. So you might want to create customer segments. If you had an online store, you might have like hundreds of features of how people behave, and you want to find similar customers and see what they're buying, and then recommend those same things to the other similar customers. You could use something like clustering, where you're taking a lot of unstructured or unlabeled data, and then you're basically clustering it and finding patterns in there. And deep learning, you've probably heard of this before. It's what's behind a lot of the major stuff that you usually see in news and really cool demos. It's killing it at recognizing and generating really complex patterns. Again, we are not going to go too deep into this, but you can look up how this works later. And actually, one question I'll ask later is like what the next workshop should be on, and should it maybe be an intro to deep learning? That might be kind of cool. But you don't always need deep learning. They're really good at finding complex patterns. And when you see stuff in computer vision and natural language processing right now, chances are it's probably using deep learning, but you don't always need this. And in fact, sometimes in certain fields like finance, somebody mentioned, if you are using deep learning, it can be hard because it can be hard to explain why it made a decision. And a lot of times, depending on what you're doing in finance, you might need to really explain why your ML model did something the way it did. And so you want to get usually a simpler model that you can interpret and understand why it made that decision. Also, deep learning can be expensive. They can be expensive to train. They can be harder to deploy. So it all like comes down to how you choose a model and what your application is going to be. Some other types, reinforcement learning. This usually learns from trial and error. It's very popular in games. So you can give an environment, and usually game environments have a really good reward function. Like, are they winning or losing? And so does anyone remember this game, Flappy Bird? I forget if it was like 10 years ago now, maybe, when it was incredibly popular. This is an example of an AI thing that was trained in the Flappy Bird environment. And it probably played this, something like millions of times. And it just got so good at figuring out where to fly in this environment. You also have something called semi-supervised machine learning, which is where you can have some labeled and some unlabeled data. And depending on the application, it can do a good job of learning patterns that way as well. Yeah, I always forget about Flappy Bird, and then I bring it up in like a talk like this, and I was like, oh yeah, this was so big. If you're around like 10 years ago, I think it was 10, maybe it was more now. So choosing a model, we kind of talked about some of the complexity things of deep learning and stuff, how you don't always need it. So again, when you're just starting out and you're doing like a toy project, you don't need to worry too much about this. I would just start with like, what type of prediction do you need? Do you need a classification prediction? Do you need a regression prediction? But as you actually are building stuff out and you want to deploy models and use them in different business use cases, one great question to ask when you're starting out before you even train an ML model is, how are you going to measure the success of your model, like in production? Like, how are you going to measure if it's doing good or not, if it's making an impact on your business? Do you need the model to be more explainable or not? Do you have hardware constraints? So not all these models can just run incredibly easy. So like the one we're going to run today is pretty lightweight, but if you have a more complex computer vision deep learning model, you actually have to think of like, okay, what's the hardware this going to run on? Can it run on something like a Raspberry Pi, for example, because I need it out in the edge in the forest or something like that? There's a whole bunch of different stuff you might need to think about. But again, if you're just getting started, you can think about what type of prediction do you need, and then kind of choose one of the models from there. And then you can try out a model and try a different model and see which one does better. And there's a cool little chart here from scikit-learn. I'll post in the chat. That's kind of like a decision tree of figuring out like what model to use. So you can use this as maybe a starting thing. Or you're looking for classification, regression. There's different types to try here. And I'm just going to walk through a couple real quick here. So k nearest neighbors is what we're going to use today. Often it's abbreviated to KNN. The k number of nearest data points. So it finds the k number nearest of data points and makes an educated guess based on the classification of the nearest data point. So here, this colored data here would be all of our training data set that we pass in. That's going to be learning patterns from. So this yellow is a flower called Virginica. This red is versicolor. This purple is setosa. And then let's say this black dot here is a new piece of data. We don't know the label that it belongs to. It's in production. This new piece of data came in. The way KNN works is it's going to be looking at the closest amount of neighbors, whatever number we pass in. So it's called a hyperparameter that we can change. Like we could be looking at the 3 closest neighbors, the 4 closest, the 5, etc. In this case, it's looking at the 4 closest, and 3 of them are versicolor, and 1 is Virginica. What do you think it would guess this new piece of data belongs to class-wise? Would it be Virginica, versicolor, setosa? Just based on what you're seeing here, what would be your guess? If you're looking at the 4 closest data points. It would be versicolor, right? Because it's looking at 4. So 1 belongs to Virginica, but 3 of them belong to versicolor. So most likely, this is probably going to belong to that class. Another common one that you might use, somebody said, sorry, there was a delay, I think, too, when I asked a question, and then so everything started coming in as I was moving on. Awesome, yeah, everyone got it right. Someone said I already tagged 3, right? So it's saying basically, well, the probability that this is versicolor is way higher because the majority of the ones that I'm looking at from that hyperparameter that was passed in belongs to that class. KNN uses, we'll see this when we actually run it too, but there's different distance measurements it uses, I think by default. Like I think you can change that too as a hyperparameter. I think it uses something called Euclidean distance. And again, when we look at the data, we'll actually see too, because we're just plotting this 2D here with petal and sepal length. But there's actually other dimensions of the data that we'll see when we run this as well. Linear regression is another popular one. You can kind of think of this as trying to draw a straight line within the relationship to these data coming in. So here we would have this kind of fit this line basically as close as we could with this data, where then if we had any new prediction coming in anywhere along these lines, it would try to predict, in this case, like going back to the housing price type one, it would try to predict the numerical value. So this is like a linear price thing again. here with the x-axis, and if we had a new piece of data coming in anywhere around here, it would try to predict the value belonging to that. Mostly we're going to look at KNN today. Actually, I will have a quick example in the notebook that you'll be able to run for this. But we're going to focus mainly just on KNN. It's a really cool, easier to understand algorithm, I think, to get started with. So other types of models that we can go deeper into, maybe in a different workshop. I actually think it might be fun to do more like just one workshop on one individual model, so we can spend a little bit more time diving deeper into them. So that might be something I do later. But all these are, well, not all these, the logistic regression, random forest decision tree, a lot of these are really easy to implement. We're going to go do the KNN neighbor today. But once you know how to do it, like how we're doing with the KNN, you can look at the rest of the scikit-learn library. It has these built-in functions that make it really easy to do these other different types of models. So we'll run one today, and you'll kind of have a good idea how scikit-learn works, and you'll be able to go look up, on scikit-learn's website or in their documentation, and you'll be able to see how to do like a decision tree versus the KNN. Enough slides. So let's go ahead and do some machine learning. I'm also going to maybe catch up on a couple questions while people are opening up these links. But also, what workshop would you like to see next? Would you want to do an intro to deep learning, an intro to computer vision, an intro to Python, anything else that isn't listed here? Let me know in the chat while we're kind of setting up for this programming portion. So I'll share this link again in the chat as well. This link will take you to a GitHub page. So it looks like this. I need to add some more details in this later. But if you want to come back to this later, feel free to start. You can fork it. You do whatever you want if you know how to use GitHub. If you don't know how to use GitHub, don't worry. We're actually not doing anything with GitHub today. You can just click on this Google Colab link here, or this Open in Colab button, and that'll take you to a Colab. Oops, meant to do that in a new tab. So take you into something called Google Colab, and I'll talk about this again a little bit more here in a second, but I can actually copy this direct link in as well. And again, these links are in the description. So if you missed it in chat, scroll down, look in the description. You can open them up there, or if you're coming back later and watching the recording, you can open up down in the description. And I'm going to catch up on some questions while people are getting ready. And once you have this open, go to File, save a copy in Drive, and this will be your very own copy of Google Colab, and you'll be able to mess with it as much as you want. Don't worry about breaking it, and I do encourage you to play around with code and stuff and see what happens. So don't worry about breaking it. You can always come back to this original link or that GitHub page and just make another copy. So open up the Colab, hit save a copy in Drive, and while you're doing that, I'm going to catch up on some questions here. A lot of people said deep learning would be a cool one. Said deep learning or NLP would be pretty cool. Computer vision. Yeah, I've actually quite a bit of a background of doing computer vision. And so I think that might be a pretty fun one. And not only just an intro to computer vision where you do something like a classification model, which is really cool. I've done a lot of workshops in the past actually teaching people how to do things like object detection, which I found harder when I was getting started. So I think that's a really cool one, and showing how to build data sets for it as well, not just the training model. Like there's so much good material on model training, but maybe a little bit more about like how to get data in and train your own object detection model might be a really cool one. And I saw a chunk of people just join. We went through slides. We're actually just getting started on the hands-on part. So if you want to go to the description, open up the Colab notebook, you'll be able to join along. It's actually kind of good timing. Someone said, can we run several model types and compare the correlation? Yeah, and in fact, it's pretty common. So you might start, or sometimes you should start with a really simple model and then see how it performs. You can add another model in basically at the same time and see how they both do, and then select the best one later. Or even in production, you can do something like that. I don't think too many people always do. Depends on the application. But you can do like ensembling too, where you're actually in production running multiple models and then choosing like the best answer from that model, or one output from a model goes to another model. But it's pretty common to compare models in production, or even before production, evaluating like, several different models, and you might evaluate several of the same model but with different hyperparameters, and like see which one performs best on your data. That's a big part of actually building a machine learning model, is evaluating which one works best and how to improve it, even before it goes in production. And then once it's in production too, monitoring it and seeing how you can improve it over time. And you can also do something where you have one model in production, serving results to users or to your business. And you might take another model because you think it could do better, or maybe eventually do better. And you could do something called a shadow deployment, where you deploy both of them. But the shadow deployed model, the results don't actually go to the user, or they're the ones that you're not actually using in your business, but you can see how it's performing. And maybe you're training that model because you think it will in the future do better with new data. So you can keep training it, have it shadow deployed until it starts doing better than your other model. And then maybe you select that one to move forward with. Someone else said deep learning. They said an intro to computer vision sounds awesome. So someone said very good job explaining and taking time. Awesome. Thank you. Yeah, hopefully this will be, I know there's so much to cover and I'm not going to get to everything that you can learn, obviously, but I hope that this kind of, again, gets you excited about machine learning and breaks the barrier of you maybe, doing it. And let me actually zoom in here. So did anyone open this up and save a copy in Drive? This will be your very own copy. Oh, and I had one other thing I was going to shout out. There's a raffle going on at my company as well with our open source product. If you want to fill this out, you can. Obviously not required for this workshop, but I was going to give it a shout out here since we're doing it anyway. If you want to win some swag or prizes, that's going on. All right. Someone said, yep, they were able to open up the Colab notebook, save a copy in Drive. So now this is yours. It's in your Google Drive. You can do whatever you want with it. This is called Google Colab. I have some relevant links up here. Google Colab is essentially Google's way of hosting what's called a Jupyter notebook. If you've never used a Jupyter notebook before, it's a really popular tool used in data science and machine learning. It allows you to write code, visualizations, text kind of all in one place. And you'll be able to edit all the code and text in this workshop. So actually, if you double click on this text cell, it'll open up and you'll see this. This is written in something called Markdown, where you can format things with different characters. To get out of this view, this edit view, you can hit Shift-Enter, and I'll go back to this formatted view. And then below here is a code cell. If you want to run this code cell, you can hit this little play button, or you can hit Shift-Enter when it's highlighted, and that will run the code and then move to the next cell. So you'll see me often hitting Shift-Enter during the workshop. When we run this first code cell, it's going to take a few seconds to actually run. If you look up here, it's actually saying it's connecting to an instance on a Google server, so it can take a few seconds. And once we're connected, then you can run this very quickly. So you could edit this if you just want to see, hello class. This is just going to be putting out text. If you've never used Python before, this is called a string that you have in this quotation marks, and then it's printing out that text to the notebook here. So cool, you're able to run that code cell. Hopefully everything will go smooth in here. Let's go ahead and start by importing our data set. So from scikit-learn, oh, and I guess I should mention too. So Google Colab comes pre-installed with a whole bunch of machine learning libraries. So actually I have scikit-learn installed. We don't have to install it. But if you ever do need to install libraries, Python libraries, you can do that very easily here using something called pip. But you won't be seeing us do it because we don't need to. It's already pre-installed. It also includes like PyTorch, TensorFlow, Pandas, some very common machine learning libraries are all kind of here. So it makes it really easy to create a little instance and then start running it. And you don't need to do this for this workshop, so you don't need to follow along right now. But if you want to change the runtime, you can actually select from different GPUs, or a GPU or a TPU. And it's a fantastic way to get started with deep learning if you don't have a GPU or like a gaming computer at home. And if we do a deep learning class or a computer vision class, we'll definitely be using that GPU because you need a GPU or a TPU to basically run these deep learning models and train these deep learning models. So it's a really cool tool to get started, and you get a fair amount of free GPU time. I forget what it is. There's some sort of cap on it, but it's actually really good for a free amount. All right, so we're going to import our scikit-learn our iris data set from scikit-learn. So from scikit-learn, this is what it looks like in Python. Basically calling this library, we're saying from scikit-learn datasets, import load iris. And remember, this library was basically already installed, so we didn't have to install it. And then we're assigning that data set to a variable called iris. And it's always a good idea to look at your data the first time you import it. So you can just look at raw data. We'll actually be doing a little bit more exploring here, which you should also do. But it's also good to just kind of quickly look at what your data looks like when you import it. There's been times where I was so sure I imported my data right, and then when I looked at it, it was not right at all. And I was like trying to train a model. I was like, why isn't my model working? And I just skipped the step of looking at the data, and I should never do that. So you should never do that. You should always take a quick little look. What does your data look like once you import it in? Here you can see it looks kind of messy. We have this big, what's called a dictionary Python. We can see that from these curly brackets. And under the key value pair data, we have an array with all these features. And those features are actually what we saw in the slides earlier. So we're going to be taking basically these features of the sepal and petal length and width, and then trying to train a model to predict what class that belongs to and find a pattern in these. So we have these features. If we scroll down more, we'll see then we have target variables, which we have 0, 1, and 2. So most of the time when you're training a machine learning model, you're going to convert the text to like the classes like Setosa, Versicola. We're going to convert those to like 0, 1, and 2. And then we can convert them back basically to the actual text name. But when we're training the model, it's going to be encoded as 0, 1, and 2. And then we have some other information about our data set, like the feature names is important. The target names or class names are features, and then our actual classes, that's what we're going to be using today. So if we actually print out the shape of it, this is kind of a good little check to do too. We can call iris.data.shape, and that's saying there's 150 rows, and there's four features to this. And if we look at the target shape, we can see there's 150 rows, and there's only one, so it didn't print out 4 here. There's only just one because it's the target values, the 0, 1s, and 2s. Now, scikit-learn makes it really easy to do a fun little example like this because you can import your own data in. But if you are working with your own data, depending on the type of data, there's different ways to import it. But I just wanted to include a little example here where if you had a CSV file or an Excel file or something like that, and you wanted to import it in, you can build in this cool little or run this cool little feature in pandas called read CSV. So it would read in your CSV file or your Excel file, and then just import that data, and you'd kind of be able to continue on like we're going to here. Somebody asked, what's a target? Great question. So target is just another name for, like in this case, the class, the class that you're trying to predict. So you'll see label and target are kind of interchangeable. So we're going to pass in this row features. That's like one instance. And then the target or label that's applied to that instance, in this case, would be Setosa, Versicola, or Jenica. So you might hear me say target or label. They kind of mean the same thing. So let's go ahead and explore our data set. So often the first thing you're going to want to do when you bring in data like this, and if you've never looked at it before, you want to do something called an exploratory data analysis. So it's a really common part of your machine learning or data science workflow. We're going to be using something called pandas. It's going to allow us to create something called a data frame, which we'll see here in a minute. But you can kind of think of that data frame as Excel in Python, where you can do a lot of really cool, powerful features. And we'll be using matplotlib for some visualization and Seaborn for some other different visualizations. So we'll see this all in action here. We're going to import the pandas library as PD. So now we can just call PD, and I'll call the pandas library. This is a really common way to import things. You import it, and then you'll kind of have a shorter word for it, so it's easier for you to type later on. And PD is like the standard that everyone does for pandas. And we're going to set an option to display all the columns here. If we didn't do that, it just might cut off some of the columns when we preview it. Shorthand, yeah, that's the word I was looking for. It's a shorthand for the library name. So then here we're going to create a data frame. We're going to call it df as a variable, and we're going to call pd.dataframe. We're going to pass in the iris data, if you remember that list that we saw earlier, And the columns are going to be the feature names. So now we have this data frame. We can call df.head. It'll return the first 5 rows by default. And we can see we have this little Excel looking thing going on here in Python. So we can visualize it like this and then do a whole bunch of mathematical operations, kind of like, again, you could think of it as Excel, but in Python. It's a good way to start thinking about it. And if you want to look at more than just the first 5 rows, you can pass in something like 10 there and start seeing them. But we see we have all those 4 features that we talked about before. And then what we're going to do is create a little bit of a bigger data frame and assign the correct classes to each instance from that data that we imported. So I'm going to import NumPy real quick. And we're not going to use NumPy too much here, except for we're just going to concatenate basically those 2 features together, or features and target together. So now we have this data frame where you have all those features, and then the target or the label that these features belong to. So now we have this data set. It's 150 rows with features and then the corresponding label for a machine learning model to learn from and then perform a classification task on similar data. So I'll call df.plot, and we're going to pass in kind of scatter. And then it's going to be a 2D plot here where we can plot the sepal length and the petal width. And then we're going to change the color on the target and then pass in this color map called spring. And that'll give us a nice little visualization right here where we can start learning a little bit about our data set. We can see that just in this plot alone that I think was it Setosa, that's 0. We'll make a prettier chart here in a second so we don't have to memorize what numbers belong to what class. But we can see down here that they're kind of pretty far, like they're clumped further away from all the other classes. So these will probably be easier to predict than the other ones. Imagine, again, you're trying to find like patterns in this data. And if you always want to make sure you're predicting purple in this case, well, you could say, anything with petal width below 0.7 and a sepal length below a 6, you could write a really simple rule there and basically always probably make a prediction in this case on the right class that was purple. This gets a little bit harder because you can see some of the yellow and some of the orange or red are kind of combined. And so you might need to kind of draw maybe multiple rules here to make a more accurate prediction. But let's look at what our data looks like. Again, this is just in 1 dimension or 2 dimensions where we're looking at the width and sepal length. But let's kind of see what our data looks like about like in all the different variations. So we can import something called seaborn. And I'm going to call something called pair plot on it, which is, I think, something really cool. We're going to pass in our whole data frame. And then we're just going to say, again, change the hue on target. If you run this, can take a little bit if you have a ton of features. Now we have all the different variations based on all the features in our data frame. So if you scroll down, you'll see petal length, width, sepal length and width, and then also plotted by sepal length and width and petal length and width. And you can now see kind of the 2D plots for all those variations. And so if we looked at just the sepal length real quick, and this is then plotted by sepal width, we can see that the 2 classes like that, the 2 purple ones here, would be really hard to find a pattern in just these features, right? Because there's so much overlapping. And kind of same in some of these other ones. And this little bell plot curve is really useful because it shows you exactly how much overlapping there is in the plotting. And we can see that all these classes have quite a bit of overlapping patterns. And so it might be hard to, not only for us, but for a machine learning algorithm to kind of come up with rules to make more accurate predictions here. And if we look at this other one, this bell curve is even worse. So this feature alone would be really hard probably to make predictions of what features belong to what class. Again, maybe for the lighter color one, the Setosa, I think it was, that one is kind of clumped out in a lot of the variations. So you could probably predict that one. But if we just were relying on these sepal features, it might be really hard for our algorithm to determine what class or what features belong to what class. But when we get to these petal ones, like the length and width, and we're looking at our data here, we can see there's much more kind of separation between those two classes. And so these features actually will probably be really important to our machine learning algorithm. And in this case, we're going to use all the features today to train our model, but this is where something called like feature selection can come in. And when you're training a model, you might have like hundreds of features and you want to pare down and use fewer. You might be looking at your data like this and start understanding how a model could determine patterns. And you might not want to put in these ones where you think are going to be really noisy and not really add to your model, making better predictions. You might want to use this data that looks like better, where you can make better predictions with it. So using a pair plot is really cool. It's a really easy way of visualizing all your features in one place and getting a quick sense of like how overlapping are all the data from different classes. And if you want to, you can pair plot with not all the features. So let's say I just want to look at the petals now in this case. If you just ran this, it would do the same one above, but you can just pass in these feature names from your data frame. So I think this should work. Where now I only want to pair plot between the petal ones. So again, you might have hundreds of features realistically in your data set, and you want to pare that down to look at only 2 or 5 or something like that. You can just pass those feature names in here. And another quick thing on visualization. So I'll just go ahead and run this. This is more just if you want to come back to it and create more pretty visualizations, you can. We're using something called matplotlib here. And you can build a nice visualization with the actual class names and stuff like that. And you could like if you want to use this in a report or something like that, you actually might want to use something like matplotlib, build custom charts, and then include this in your report or documentation. So I have a lot of notes in here. We can come back to this if you wanted to. But you put an index 1 through 3. And then this little formatter thing just basically is getting the names. So like the Virginica versicolor and Setosa. And then you can mess around with these too. Like if you want to make this a bigger figure or have higher, I think it's dots per inch. So you can have a higher definition one. And if you want to change the colors and stuff, you can in here as well. All right, so enough on the exploratory part. Let's go ahead and get to the machine learning part. And this is where, if you've never done machine learning before, you're about to do machine learning for the very first time, which is really exciting. So now that we have looked at our data, in this case, we didn't actually have to clean it up because it's a pretty clean data set. A big part of machine learning and building data pipelines and stuff in the real world is often your data's messy and you have to do a whole bunch of things like clean it up, do feature selection, feature engineering, et cetera. There's often a little bit more to that data side. But today we're lucky. We have a nice little clean data set. We can actually go ahead and train our model. And how we're going to do this is we want to build a training data set and a testing data set. So we're going to use that whole data set that we imported. And I'll just walk through the code here, actually, and I think that'll hopefully make sense. So we're going to import neighbors from scikit-learn. That's going to include that k-nearest neighbor algorithm that we talked about earlier. And then we're going to import something called train test split from model selection. And then we're going to assign the data and labels to X and Y values. So this is really common notation in data science or machine learning. Is you have a capital X, that means that's going to be your features. So again, the features are these measurements here. And then a Y value is going to be the label or target. And we're going to pass those into our machine learning algorithm, and it's going to learn patterns from that. So we're going to create a training and testing data set here. We'll talk more about how this works here. But if we just took all the data and trained our model, we actually wouldn't really have a good idea of how it's working. So what we're going to do is split it up, and we're going to save 20% of our data as test data. And we're going to use the other 80% to train our model. And then we'll use that 20% of the data and see how our model does on it. So it's data it's never seen before. And it's going to be looking at for the first time. And then it's going to make predictions. And then we can get things like an accuracy score to see how good our model did. So we're going to create 4 variables here from this train test split function: the X train, X test, Y train, Y test. We're going to pass in the X and Y, which again, that's the data, and then our label. We're going to say test size is 20%. So it's going to save 20% of the data, not train our model on it. Random state is if you ever want to come back and so this is kind of shuffled. It's shuffling our data as it goes in, so it's not just cutting off on, like if it had all the Setosa and versicolor, but it never had Virginica in there, we want to make sure that's shuffled in there. And actually, that's what Stratify is doing as well, is it's trying to make sure that it's getting an even sample for each class as much as possible. But random state just means we could pass in the seed of 21 again, and it would be kind of shuffled in the same way. So if we actually had to come back and look at how our data was arranged when we trained a model, we could pull it back out. And then here, we're going to assign a variable knn to our neighbors.k nearest neighbor classifier. And this is, oops, I should have changed this. You could change this right now if you want. I recommend it, but you could leave it as 1 if you want. This is the hyperparameter where we're going to be looking at the x or k closest neighbors. So 3 is going to be looking at the 3 closest neighbors to this, to whatever the new data is. So if you remember that graph that we had before, where we're going to have new data come in, and then it's going to be looking at the 3 closest neighbors, in this case, with that hyperparameter. Otherwise, it's just going to be looking at the 1 closest neighbor, which you still might get good predictions on it for this data. We can test it out and see what happens later. And then we're going to call knn.fit. .fit is another word for training. So it's fitting the model to this new data. We're passing in the training features with the training targets. So it's going to kind of learn patterns from these features to map over to those labels or targets that we're passing in. And then we're going to do a prediction on the test, the test data set that we held out. So let's go ahead and run this. And if you've never done machine learning before, you trained your very first model. So, I mean, you could put machine learning on LinkedIn if you wanted to. I saw that you did it, right? Now let's run this next code cell. This is going to go ahead and print out the actual values these are the predicted values from our model up here. And then these are the actual values. So we can compare these. And if we're manually comparing them, forget it. Maybe if you see if one's wrong, we'll see a better way to see the score in a second. But most of them look right. So like this is predicted 0, and it actually was a 0. Predicted a 2, it actually was a 2. Predicted 1, it actually is a 1. And we can manually go through and see how it did. Or we can call this dot score and see how well it did on the X test and Y test data. And it's 96.6666667 accurate. That's like the score it got. So I think there's 1 in here that's wrong, and I don't see it visually, but it got like 1 right. So our model is 96% or 97% accurate based on the test data that we had. And if we want to, we can use something called a confusion matrix, which is a kind of a cool way of seeing how well it did per class. So we can import something called confusion matrix and a classification report. And then we're going to pass in that target test and target prediction data again. And now we can see that for class 0, it got them all right. For the middle class, it didn't get it all right. It got 1 of them wrong. 9 of them were right, and 1 was wrong. It actually predicted that it was class 2. And we can also have kind of a better way to visualize this with this like heat mapping. And again, we don't have that many, that much data here, but if you had like hundreds or way more classes, it can be really cool to have this kind of heat map to see how well it's been doing on these different classes. And I'll just do a quick note. So you can run this classification report and get more scores like precision and recall, F1 score, which accuracy isn't always the best score. And one example I like to say, or how to illustrate that is like if you were building let's say, I don't know if it was a computer vision is a really good example, but let's say it's a computer vision model and it's trying to detect at an airport that suitcases don't have a gun in it. So it's like trained to detect guns, and it's designed to detect it from an X-ray. Well, if your model, like let's say, 99%, probably more, 99% of people though in this example going through the airport X-ray don't have guns on them, but maybe 1% did. Well, if your model just always predicted there was no gun at all, so like you either trained it really poorly, or maybe you didn't even train it at all, or it was on completely different data. If it just always predicted no gun, it would still be a 99% accurate model, right? Because 99% of people don't have a gun. So you'd actually want to have something that has like a higher recall rate where it might be wrong a little bit more of the time, but it's doing a better job of predicting like when there's a gun versus when there isn't. So classification isn't always a really good or sorry, accuracy isn't always a really good metric to use depending on your application. You might want to look into using these other methods like precision and recall. Somebody said SNS is not defined. Probably you missed running this code cell up here. So it's kind of right underneath this visual. Usually, if you're going to get an error in here, chances are either you changed something in the code or you just forgot to run a code cell. So if it says something's not defined, go back and try to run that. Right. So, oh, and a quick note too. So I think this is fun to talk about as well. Actually, let's go ahead. We'll wrap up these code cells. I think we're just a little bit over time here too. Actually, around at the hour. So one, how does everyone feel? I know we went through really fast. A lot of it's pretty high level. But if you never did a lot of machine learning or maybe never machine learning before, how do you feel now going through and kind of seeing what it looks like a little bit? Do you feel like, you could do machine learning? You have an idea, maybe like an intuition of how like models kind of work, and maybe you thought it'd be way more complex. But there's a lot of really great libraries and resources out there that kind of make it like, again, I don't want to say it's always easy for you depending on your background, but hopefully it was way easier than you thought. People said, great job, really good. Awesome. Yeah. Hopefully you feel like, and again, totally okay too if you feel like, oh, this was a lot and want to come back and dive deeper into things. Like that's totally normal too. Just depends on your background. But hopefully this is like felt like it was approachable, even if you didn't have a lot of background in programming or machine learning. And diving into these different algorithms, like you don't need to always know all the math behind them. Like you can read books on it and it's good to know, but the important thing to really know is the intuition of how they work. So like this is a pretty simple algorithm. If you have more complex data, this one might not really do a good job of doing what you need it to do. So you should probably take a look at like models that work in more complex data, like decision trees or random forests, etc. So knowing that, like an intuition of like, this is kind of how this model works, even if you don't know the mathematical formula behind it, like that's totally fine. And you can do that kind of with most of these other algorithms, like look up how a decision tree works and kind of get a good idea and you'll build up a really good intuition of what model you should be using. It's just something you kind of get a feel for the more you do it. Awesome. So people said, I think most people said they're feeling great. And this is a good intro. That's awesome. Glad to hear it. We have a couple more code cells we can run if you can stick around. So we trained our model and we saw that based on that test data that we saved, it was 96 or 97% accurate. Let's run our model on some new data that we can manually enter in and see how it behaves on different data that maybe isn't even close to what it was in the data in the training data set. So let's go ahead and we created an array here. So we're going to put in the feature names. We're going to create a function in Python. This is what it looks like. You say def as a keyword, and then we have this function. So a function we can now kind of call over and over without having to write all this code again and pass in new data and just basically reuse code by passing in new data. So if we run this function with this data here, and I encourage you to mess around with these numbers and see what happens. So we can see that it's kind of a probability score that it's returning here. And this would mean that because I changed my K number to 3, again, if yours was just 1, I think all these numbers will be just 100% on one of these classes. But here it predicted that, this distribution of features would belong to versicolor. What would happen if we put a really crazy number in here? Somebody shout out 4 numbers, or 4 people put in different numbers, and let's see what happens. So remember, like our training data set is in a distribution of something like this, where our sepal length is no more than 8. and our pedal width is no more than 2.5 or 3. What do you think would happen in this case if we put some outrageously different numbers in here? So someone's a -1. Let's do that for the first one, right? That's not in our distribution at all. Let's say 200. That's way outside of distribution. Let's say another -1000. And here, I'll put that someone said 45. All right, so I'm going to run this, and let's see what happens. It predicted that it belonged to Setosa, which is kind of interesting, right? Even though it's outrageous, like that data doesn't look anything like our training data set. Well, what happened is we didn't have any rules on our data or any test cases on our data. So Setosa is this one that's all the way down here, and we had a lot of negative values in this case. So our data could be like way off the screen down here, not even anywhere close to these, right? But the way that this algorithm works, it's still looking at the 3 closest data points. So even if it's way over here and not anywhere near it, it's still saying, well, the 3 closest ones are Setosa, so I'm very confident that it belongs to that class, which is kind of funny. And this is going to be a big problem too, or something to think about when you get to putting models in production and handling more messy data sets. Like production data, there's always going to be weird use cases that you probably forgot about or you didn't account for, which is wild, right? And yeah, so someone put in the chat, you want to assess for outliers, and there's really cool tools that can help with that. One is also a tool that we help maintain at Union called Pandera. You can check that out. There's other ones as well. Deep Checks is a popular one. I used to work at another company. There's using a tool called Ylogs. So there's a lot of these really cool tools that you can check out to kind of write unit tests for your data. And you make sure that this looks like it should, like how I'm expecting it. So you could write a test saying, well, if the data is above 8 for sepal length, or maybe you're a little more, you want to have a buffer room in there. So you're saying it should always be under like 15 or something like that. But if it's way outside of the realm, then maybe you don't run a prediction on it at all, or you do run a prediction, but you log that you think it was an outlier, and then you as a human can go back and see what happened there. So there's a lot of cool ways that you can build out these kind of tests for it. And I'm going to actually skip I thought about removing this earlier, but I left it in here in case you want to go ahead and run this code for linear regression. It's doing very similar stuff to what we did before, but we're importing a different data set here that you can actually run linear regression on, and you'll get some results here. So I'll leave that up to you to play around. But we're over time here, and I got to run in a couple minutes. So I just want to say, keep learning, especially if you're newer to machine learning and you want to keep diving down the rabbit hole. There's so many great resources to do so. Feel free to connect with me on LinkedIn. Oops, I forgot Colab does this other link now. So if you want to stay connected with me on LinkedIn, I always love hearing from people and seeing what you get up to. If you want to check out more upcoming events, I think a lot of you already came from Meetup, but I'll post this in the chat as well. You can join that if you're not already on it. And then if you're looking for more advanced machine learning stuff, definitely check out the blog at the company I work at, union.ai. Again, a lot of our stuff is around MLOps and productionizing models. So maybe you're newer and you're not ready for that yet, but hopefully will be soon, which will be really cool. And then also, if you want to check out our open source project that allows you to do a lot of really cool stuff by helping put models in production and tying all these different tools together. We just really touched the surface today of what it looks like to really build something with machine learning, and it's really exciting. There's a whole bunch of other stuff that usually goes on, putting in production and tying all these different tools together to help clean your data, process data, train a model, monitor your model in production, and then when something happens in production, maybe you want to take that new data, retrain your model, and we're a tool that can really help with that. And if you want to give us a GitHub star, that's always appreciated as well. And I think, just the one last thing is, if you want to join a Slack community of, ML and MLOps practitioners, you can join us at this union/Flight1. And I think there's, again, almost 3,000 people in there. And I'm trying to do a lot of cool stuff around not just Flight in there, but also just discussions around machine learning and AI news. And you might have also seen, if you're in the meetup, the AI book club, which we had almost 100 people come to this week, which was really cool. Right now, we're reading the ML system design book. Oops, that's the wrong one. So if you want to check that out, I recommend it as well. The book is really good. Again, it's kind of, if you're super new, you might feel a little overwhelmed by it, but it's a really good introduction to thinking more about ML ops. So someone here earlier was talking about how they're a data engineer and they're thinking about going more into ML and ML ops side. This book would be a really good intro for you, I think, about thinking how to build and design these machine learning systems. With that, though, I'm going to kind of wrap up soon, but I'll be hanging around for a few minutes to answer any questions people have. So with that, again, also, if you want to say, well, I think a lot of people said this is a good intro before. I know we went pretty fast through a lot, but again, hopefully you had fun and you actually were able to train a machine learning model today. I think that's really cool. If you've never done it before, saying, that you were able to go and within an hour, learn some intuition around machine learning and then train a model. Like, hopefully it feels a little bit easier. Somebody said, thanks. The career change seems daunting, but constant learning will make this possible. Definitely incredibly interesting. Yeah, obviously there's a lot to learn and it can take a while to feel like confident in the field. But yeah, keep going through material. One of the best ways is to, train different models. And if you have fun side projects, that helps a lot. If you have something you want to try to do, like with computer vision or any other type of ML system, or just take other toy data sets. So scikit-learn has other built-in data sets. We just looked at the Iris one today, which is really it's like kind of the famous one. It's almost like the hello world of machine learning, but there's other ones built into there. Start with those maybe, and then try bringing your own data in, even if it's also pretty simple. And in an Excel sheet, you'll learn a lot about, I need to bring data in. Oh, the data is not formatted correctly. I need to now format this data. Now I need to train the model. So there's a lot to do. If you've never done it before for a career change, but hopefully not too much. Like, it is something that you can sit down and go through a lot of resources. Like, there's so many books, there's so many great online courses that if you put a lot of time into focusing, it's hopefully easier than you were thinking before. Like, it's definitely a very doable thing. And there's so many great courses on like Udacity or Coursera or DataCamp. And depending on your skill level, like ramping more up in Python and then quickly going more into like pandas and doing data manipulation and then training models. But you can see that it's not super hard or like rocket science to get data into a model and get a result from it. There's just like a lot of knowledge you can build up from using different types of data and different models. And if you did join the community, the Slack community, say hello in the introductions and tell me a little bit about yourself there. And I'll definitely try to say hello back and stay connected with you. And I'm excited to see what people build. Someone said, good distillation of a lot of topics. Yeah, it's a lot. So again, I know, don't worry if it felt overwhelming to some people. We did speed through quite a bit. But if you followed along, you were able to actually run code and train a model. Awesome. And again, links are in the description below. So if you want to go to the GitHub repo later, Colab link, the Slack channel, slides are in the GitHub link. I think everything is kind of down there that you should need, but reach out to me on LinkedIn or Slack if you have any specific questions. But with that, I'm going to wrap up the stream. So again, thank you. I see a lot of people said thank you. I see them all. Thank you so much for talking in the chat too. It makes it way more fun for me. So I'm not just talking to like a blank screen. Seeing people react is really fun. So again, thank you for everyone who joined in. And especially thank you to everyone who spoke in the chat and asked great questions. Also, sorry if I missed some because there was a lot of chat, which is awesome. And if I did miss questions, feel free to ping me in Slack too or on LinkedIn. Awesome. Thank you, everyone. I'm going to wrap up the stream. I'll hopefully see you all at different events or in Slack later. And hopefully we won't be strangers. Have a good night.